Ready for E. So let's see what this one, we had a couple kind of strange ones. Let's see what this one has to hold. All right, this one has a little bit of a, you guys, none of you got one?
Or do you think that one is three? You think that one is two?
You're a little bit big to come see.
What? That was a B. That was a B. It was not me.
All right, here we go. Now, there's one oddity about this problem that is a review. Look at the highest power of x. What do you notice in this problem? We talked about this earlier in the year. What do you notice about the highest powers of x? They don't match, right? The powers don't match. And the big one is on the bottom. Does anybody remember what that means when the powers don't match and the big one is on the bottom? Where is that asymptote? Zero.
Yeah.
So my horizontal asymptote is at 0. Literally, kids, there are no x squareds on the top and 1 x squared on the bottom. 0 over 1 is 0. When the big power is on the bottom, your asymptote is going to be at 0, which means it's right here. Now, what about vertical asymptotes? Well, I probably should factor the bottom. Top does not factor, but the bottom will factor into x minus 3 plus 1.
Yep.
Two things. First of all, no hold. Because even though I could factor, I still have no canceling. Soon, I promise, we're going to get one, but we don't have it here. Second, there are 2 vertical asymptotes. Because if you put in 3 or -1, you would get a 0. And vertical asymptotes happen when the denominator is 0. Right? So let me put those in, 2 of them. All right, so this is our setup so far. Oh, this is a tricky problem. You won't have anything this tricky. But let's finish it since we got started. Where are our intercepts? Let's find our intercepts. How do we find those again?
0.
We put in 0 for each letter. So I'm going to put in 0 for x first. If I put in 0 for x, it looks like I get 5 over -3. If I put a 0 in for x, wouldn't it be -3? So 0, -5/3. And if you're ever wondering about where to plot that, remember to make it a mixed number. So that would be 1 and 2/3. So it's between 1 and 2.
Yeah.
Wait, for the y-intercept, I thought you put in 0, it'd be -3 and then +1 on the bottom, so it'd make it -2, right?
You're multiplying. Those are factors. You're multiplying. All right, my x-intercept, I'm I'm going to let my problem equal 0. I'm putting in 0 for y. Can you tell me already where that x-intercept's going to be? Remember, it comes from the numerator, so the x-intercept is going to be -5. Yeah, I'm sorry about this. This is a little tricky. I know what part of it looks like. In between the asymptotes, it has to look like this. How do I know that? Now there's a point. That point's got to be there. So I know it has to go through this point. Could it come down from the top? No, because it's not allowed to cross. So if there's one point down there, they all have to be down there. Because it can't cross. There's no intercepts up here. Now, what about over here? This problem's really tricky. What about over here? Could it look like this?
Yeah.
Yep. Could it also, though, look like this?
Yes.
Yeah. I have no idea which one it is, so I am going to have to plot a point. So this is 3. That asymptote's at 3. So I'm going to see what happens when I plug in 4. So I'm going to put 4 into my problem. So if I put in 4, I get 9 over 1 times 2. 5, I'm sorry, 5. I'm putting in 4. So I get 9 over 1 times 5. That's 9/5. That's a positive number, isn't it? So if I put in 4, I'm plotting up here, aren't I? So it must be that one. Now over here I have the same dilemma, right? Because I don't know whether it goes down this way, it could, or whether it goes up this way. It could, I don't know. Because all I know is it goes through that point. So, what could I try? This is -1 and this is -5. What could I try? -2? And I'm checking to see if I get a point down here or a point up here. Because that's going to tell me how I will connect the dots. Alright, so let's put in -2 and see what happens. -2 would give me 3. -2 is -5 and -1. Now all you really care about, will that be a positive or a negative number?
Positive.
That's going to be positive, which means it's plotted up here, which means it looks like this. Now you're not going to have anything that wacky. But I am kind of glad it happened because you see what I do when I get stuck? I plot a point. If you really don't know, there's 2 options. Plot the point and then you can figure out which one it is. That is a wild problem for sure. Crazy. Alright, let's see. Hey, we're almost done with this section. That would be awesome. All right, here we go. Y equals. Is there anything you notice right now that you want to take care of? There is going to be a hole, but even before I get there, I'm going to do my horizontal asymptote. What can you tell me about my horizontal asymptote? 1. It's 1. Would everybody agree with that? X squared over x squared? So I'm going to have a horizontal asymptote at 1. All right, now I guess I better factor. So I know the bottom is x plus 1, x minus 1. What about the top?
X minus 4, x plus 1.
Oh, the moment you have been waiting for.
Oh, there's a
Look, see how it cancels? So now I want you to do two things. I want you to rewrite the new problem, which is x minus 4 over x minus 1. And that is now the problem. We're not going to look anymore at any of this. We're only looking at that now. And then the other thing I want you to do is come over here, and where you've been writing none, you are now going to put a point, and the point is going to be where x is negative 1. Now, why is it where x is negative 1? Because that's what I canceled out. I canceled out x plus 1, which means x is negative 1, because I always do the opposite when I have x in parentheses, right? So whatever you cancel gives you your x. Now, how do you think you'll find the y part of that?
Plug in the
You're going to plug it right back in, but you're going to plug it in over here. This is now your problem. This is where you're looking. So if I put in negative 1, I'll get negative 5 and negative 2, which is 5 halves. So I'll come over here, and I'm going to plot a point at negative 1, 5 halves. And if you are confused about where to put that, write 5 halves as a mixed number. What is 5 halves? 2 and a half.
Wait.
So,
Yeah, isn't it positive?
oh, it is positive. It is positive 5 halves. Thank you, folks. So 2 and a half, negative 1, positive. So here's here. Thank you. A little bit of a difference there. Thank you very much for pointing that out. So negative 1, positive 5 halves, 2 and a half. Now, do I have any vertical asymptotes? Remember, you're looking in the box now. We're not going back to the original problem. Look at the box. Do I have any verticals? X equals 1. There's my vertical asymptote right there. Do I have any intercepts? Remember, you look in the box. What happens in the box if you let x be 0?
Negative 4.
You get positive 4, don't you? So I have a y-intercept. Clear up here and erase that. Clear up here. It's my y-intercept. And what happens if I let y be 0? Solve that. X is 4. Now you only have one vertical asymptote, so that keeps the picture more like this. Anybody see what it looks like? See this point right here? That kind of tells you we got this going on, right?
Side, you got the same thing.
And you got the same thing up here. Now remember, the point and the intercept are both, the hole and the intercept are both part of it. So you're going to go through the hole and the intercept, and as you move, you're getting closer all the time to your asymptotes. So as we go up, we're squeezing over toward that asymptote. As we come out, we're getting closer to the asymptote. That's pretty cool. All right, well, there's one more, lucky us. What part of all that's the hardest for you? Anybody have a part that's hardest? Okay. Since it's all easy, we'll just jump right in. What do you want to do first? Factor? Alright, we can do that. So, oh boy, be careful with that top. 2x and x have to be minus 3 plus 1. Now remember, as I'm factoring, I'm not magic, I don't have this problem memorized. As I'm factoring, I am foiling to check. So my little bind is saying negative 6x, positive 1x. That gives me negative 5. That's what I'm thinking as I'm doing it. I'm guessing just like you are. The difference is I always check, and some of you forget that part. You need to check. Negative 6, positive 1 when you foil. Now what about on the bottom? It's a little easier. X minus 1, x minus 3. You notice? So now your problem is this. This is your problem. And the fact that you canceled means you will have a hole. And where will it be? Look at what you canceled out. It's going to be where x equals 3. It's the opposite of whatever factor you canceled out.
Plug it in, you get 7 over.
So then we're going to plug in 3. So plug in 3, what do we get?
7 over 2. 7 over 2.
7 over 2 if we put in 3. So I'm going to plot that point, hopefully correctly this time. And positive 3, what's 7 halves?
3 1/2.
3 1/2. So it's going to be like right here. Nice little open dot at the point 3 comma 7 halves. All right, all of your energy is focused right here on this box. Can you tell me anything about my asymptotes?
Horizontal is 2.
Horizontal is y equals 2, because if you look at the problem, it's 2x over x. If you had done that from the beginning, it still would have been 2, wouldn't it? Because it's 2x squared over 1x squared. All right, look here at the box. Can you tell me anything about vertical asymptotes? Ashley, come. Where's my vertical? X equals 1. Why is that? That's what would make the denominator 0, right? You put a 1 in, don't you get a 0 down there? Now, what about my intercepts? What happens if I put 0 in here? I'm plugging in 0. I'm physically plugging in
1 and
0.
negative 1.
I get negative 1. Is everybody following? If I put a 0 in, I get 1 over negative 1. So that's negative 1. That's my y-intercept.
Then you get 1/2.
And now I need to set it equal to 0. So I'm going to set this equal to 0.
Negative 1/2.
And remember, when you do that, you actually solve this part, right? Good? So what does that equal if I solve that? Negative 1 equals 2x. Did you get negative 1/2?
Yes.
Which is right here. Now, once you've plotted all these things, then you got to figure out what the picture looks like.
That's the hard part.
But if there's only one vertical asymptote, which there is, just one, it will always be something like this. Okay?
Noted.
So given the points that you've got, see that up there?
Mm-hmm.
I think it must look like this.
Mm-hmm.
Okay, now these two over here are you seeing something like that?
Yep.
Now, if you try to draw something else, just remind yourself that it cannot cross the axis any place other than where you have dots. So don't be looping it down because it can't cross. And then also remember that as you head off the page, you have to be getting closer to an asymptote. These are never going to do something like this. Your polynomials did that. Remember, start down, end up. That's what polynomials do. But these guys will always, always, always get close to their asymptote. As you go off the edge of the page, they're always going to get closer to their asymptote. Okay? All right, so here's what we're going to do. Tomorrow, I will have a practice quiz ready for you, and we will go through that. And then you will have 5 days to practice your practice quiz. And then